This video will be a basic summary of the properties of radicals. This shape right here is a radical. Sometimes we call it the square root when there's no other number here. So for now, we can assume we're talking about square roots when we see this symbol. The first important property of radicals is how they behave when they're added together. We can actually treat them something like a variable. So looking at this first equation, if I have the square root of 2 and I add the square root of 2, well, that's like having an x and adding those, or an apple and adding those. So I just have 2 square roots of 2. And you can write it just like that. With the 2 in front, it really means 2 times the square root of 2. So a second example here, if I have a square root of 2 plus the 6 square roots of 2, that's like having 1 apple times plus 6 apples. So I would really just have 7 square roots of 2. Looking at this third example, I'm actually not going to be able to add them. They are totally different numbers. It would be like trying to add x plus y, or apples plus oranges. It actually can't be simplified. So this just stays as the square root of 3 plus the square root of 2. It's worth mentioning that subtraction would actually work exactly the same way. So if I had changed, let's say, this second problem to instead of a plus sign, I put a minus sign, I would instead have had not 7 square roots of 2, but negative 5 square roots of 2. Multiplication and division work slightly differently, but they're actually way easier. So if I do, this time, if I do square root of 3 times the square root of 10, I can actually combine the 3 and the 10 underneath the same square root. So I could just do 3 times 10 under one radical, which would then change into the square root of 30. Looking at the second example, square root of 3 times the square root of 3, well, that's going to be the square root of 3 times 3. So I combine both of these under one radical. Well, that's the square root of 9. And I know the square root of 9, so that's 3. So I can simplify that down even more. Division is going to work the same way. So if I do the square root of 20 divided by the square root of 2, I can rewrite that as one big square root of 20 over 2. Well, I know 20 over 2, so that's going to be the square root of 10. One last example, just to make sure you're getting it. This would be the square root of 20 times 5. Well, I know 20 times 5 is the square root of 100. And I can simplify that because I know the square root of 100, and that's 10. So you always want to make sure if you know the square root, so if this number under the radical is a perfect square, make sure you simplify that down. We know that 10 times 10 is 100, so that's why the square root of 100 would be 10. The reason those properties of multiplication are so important is because they allow us to simplify radicals. So for example, what I mean is I'm going to look at the square root of 20 here. And I happen to know that 20 is 4 times 5. So there's no reason I can't just write it as the square root of 4 times 5. Now, it's true that 20 is also perhaps the square root of 10 times 2, but in a moment you'll see why I chose to break it into 4 times 5. Now, I know from my properties of multiplication that if I have 2 separate radicals, 2 separate square roots, I can make them 1. So if I have 1, there's no reason I shouldn't be able to make them 2. Now, we know the square root of 4. So I can change that to 2 times the square root of 5. So I have simplified the square root of 20 to 2 times the square root of 5. Now you might be wondering, how did I figure out 4 times 5? Well, really what I did was I looked at 20 and I thought to myself, are there any perfect squares that are also factors of 20? And there are. 4. 4 is a perfect square that is also a factor of 20. So that's why I wrote it as the square root of 4 times 5. Now if I had chosen 10 times 2, unfortunately neither 10 nor 2 are perfect squares. So getting to this part, the square root of 10 times the square root of 2, really doesn't help me at all because I can't simplify those anymore. Now I know I'm done here because 5 does not have any factors that are also perfect squares. 5's factors are 5 and 1, neither of which are perfect squares, so I'm all done. All right, let's look at one more. So I see the square root of 27. So I'm going to think to myself, do I know any factors of 27 that are also perfect squares? Well, factors of 27 are 1, 3, 9, and 27. And are any of those perfect squares? Yes. 9 is a perfect square. So I'm going to write this as the square root of 9 times 3, which simplifies to the square root of 9 times the square root of 3. And I know the square root of 9 is 3, square root of 3. So I know I'm done here because the square root of 3, its factors are just 3 and 1, neither of which are perfect squares. Let's do one last example to make sure you're getting this. So I'm going to look at the square root of 32. And I'm thinking, are there any perfect squares that go into 32, that are factors of 32? The first one that comes to my mind would be 4. Maybe you can think of a different one, but let's just go with the 4. So I'm going to have the square root of 4 times 8. So square root of 4 times square root of 8. Awesome. So now I have the square root of 4 is 2, and then I'm just going to leave the square root of 8. Done. But wait, let's check. Are there any factors of 8 that are also perfect squares? Yes, 4 is still a factor of 8. So I actually have to keep going here. So what I really have is 2 square root of 4 times 2. 2 square root of 4 times square root of 2. So really, I'm drawing this out way more than really necessary, but what I really have is 4 times the square root of 2, and that would be my final answer. So what I was trying to get at with this example is that you also want to pick the biggest factor of the original problem that's also a perfect square. If you don't, not a huge deal. You just have to do this whole extra step. But if I had listed out my factors of 32, I would have gotten 1, 2, 4, I think the next one is 8, 16, 32. And notice I chose 4 to start right here. But if I had chosen 16, I actually would have skipped a whole lot of extra work. So let me just do it quickly with 16. Let's change the color. So let's say I'd picked 16 at first. I would have had the square root of 16 times 2, which simplifies to the square root of 16 times the square root of 2, which would have been 4 square roots of 2. So that was a whole lot less work to get the same answer. So just be thinking about that. To finish off your homework, I'd like you to do these 4 problems. In number 1 and 2, you're going to condense. And then in number 3 and 4, you're going to simplify. So that's the process where you want to think of factors that are also perfect squares. Good luck.